to all of you. This session is regarding that international intermediate chemistry, which will be fetching for your entrance or any competitive exam you're aspiring for. India is conducting JEE Advanced, JEE Mains examination twice a year. That is for IIT and NIT stream. That is the technical domain. Get the admission into IIT and NIT stream. And NEET exam will be conducted across India, that is for medical entrance examination. In addition, Telangana and Andhra Pradesh government are conducting MCET examination for BTech stream, that is the admission into BTech. So all these are cumulatively conducting the exams based on intermediate syllabus only. And in addition, if you're aspiring any government related exams, competitive exams, we can say, so that government jobs having multiple subjects, multiple dimensions, multiple kind of post categories you can notice. Among all, one is the general studies question paper will be there, that is common for all the aspirants. In the general study, general science is the content what we are discussing. Intermediate chemistry is very much fetching for that general science. Okay, let's go with the content what we are going to discuss today. The Nobel Prize in Chemistry 2020 was awarded jointly to Emmanuel Carpenter and Jennifer A. Donda for the development of method for genome editing, right? It is the genetic related invention, and for their contribution towards this kind of advanced technology in the gene editing, we can say the Nobel Prize, the prestigious Nobel Prize, is accorded in the field of chemistry in the year 2020. Two women scientists received this kind of highest privileged award, we can say. So both got laureated by means of Nobel Prize. One is Emmanuel uh, Charpenter and Jennifer A. Donda. So for the development of genome editing, right? So let's go with these two scientists received the Nobel Prize. Here, Emmanuel Carpenter, here she is contributed half of the research for this Nobel Prize, and Jennifer A. Donda, she also contributed half of the share for this Nobel Prize. Okay. And the Royal Swedish Academy of Sciences laureated these two scientists together in the field of chemistry, and this prize was given in the year 2020. So here, Emmanuel Charpenter is the scientist, Max Planck Unit for the Science of Pathogens, Berlin, Germany. She representing Germany, and Jennifer A. Donda, University of California, Berkeley, USA. She belongs to United States of America. For the development of method for genome editing, both together contributed for the research in the field of genome editing. So their outstanding contributions got recognized by this Nobel Prize and accorded in the year 2020. This is regarding the brief intro about the scientist who shared this one. Now we will go with their work of recognition. So what work they did and how it is recognized, right? Genetic scissors. So just now we know that. So here genome editing is the research criteria in order to select for this Nobel Prize in the year 2020. Okay, editing is nothing but everybody aware about how can we do the editing. If you go with the entire video, if you want to pick the selective regions, so what we will do, we will go for editing. We can cut short all the unnecessary things, and whatever things you actually require, that can be taken and aggregated together, which is called a normal editing. In the similar manner, genetic editing, genome editing is also carried. So by means of genetic scissors, you are supposed to use this kind of scissors in order to cut short whatever unrequired or undesirable kind of materials or genes are present. They get scissored, right? The tool in the field of medicine, rewriting the code of the life. So everybody aware whatever genetic matter is there in the living organism, that is the fundamental in order to drive your entire characteristics, entire way of thinking, thought process, and all kind of activities of human being are purely driven by this genetic matter only. Some of the genetic matter is imbibed through the hereditary factors from the four generations, and some will be acquired within the human or within the living organism by means of the environmental uh, adaptations. This is the way the genetic matter will be developed within the living organisms. But these scientists, what they are doing is they are using genetic scissors. They used to cut short whatever undesirable genes are present, and they used to introduce the requisite genetic code of life. This is nothing but rewriting the genetic code. This is a kind of new way of life can be attributed by means of this new kind of research, we can say. Emmanuel Charpentier and Jennifer A. Domino have discovered one of the gene technology's sharpest tool. The tool which is they invented for this kind of rewriting of genetic code is CRISPR. Cas9 genetic scissors can be used. The technology what they adopted is called a CRISPR Cas9 genetic scissors. Using these, researchers can change the DNA of animals, plants, and microorganisms, right? So here being genetic matter purely relying on the deoxyribonucleic acid and ribonucleic acid, these together are regarded as the genetic matter, right? So by means of the technology they adopted, CRISPR or Cas9 genetic scissors, researchers are able to change the DNA of animals and even plant materials and microbes, small tiny organisms. What you can notice, their kind of genetic mapping is also possible, right? So extremely high precision by means of whenever they are doing this one, the precision rate will be extremely large, so that most of the cases they will go for the success only, right? This technology has revolutionary impact on the life sciences and is contributing to new cancer therapies, right? So whatever genes causing the carcinogenic activity, we can cut short them, so that it is the kind of new kind of curation, new kind of medication in the field of medicinal terminology, pharmacopoeia, we can say. Cancer therapies, you can apply this rewriting of genetic code and may made the dreams of curing inherited diseases come true. Okay, some of the people are suffering whatever their forefathers are having, and the same will be transmitted through the genetic matter, and they're able to go for the same kind of disease, and the same kind of things will be happened, that will be repeated further because of hereditary action. That kind of hereditary diseases, inherited diseases also curated, because we are going to cut short all the what disease causing genetic codes, triplets, we can say, right? So that can be entirely removed, and a rewriting of code is possible, so that we can go for the curation. Especially in the medical field, it is a kind of new invention of high impact. Researchers need to modify genes in cells if they are to find out about the life's inner working. This is used to time consuming, difficult, and sometimes impossible work. Using CRISPR technology called the Cas9 genetic scissors, it is now possible to change the code of life over the course of a few weeks. Okay, so in order to modify the cells, what genetic matter we are having, in order to modify them, or else in order to change their interlinkages, that is extremely time consuming process, and sometimes it may not be possible, and we can say it is impossible process also. But the advent CRISPR technology, whichever they adopted, that is the kind of efficient in nature. Within a short span, within few weeks only, we can accomplish the kind of rewriting of genetic code, and these are called genetic scissors. It is a kind of new revolutionary impactful research in the field of chemistry, which mainly used for the healthy survival of society, right? That's the reason why this Nobel Prize is accorded in the field of chemistry 2020 for this genome editing, right? So move on to another content. Question number 2, we can say this question number 2 is collected from Cambridge Assessment International Education. Here, metal name was provided, and these metals, upon treating with the cold water and also the hot water, we can say steam. Hot water is said to be steam. These two conditions are provided to you. Under these two conditions, how these metals are working and what is their reactivity order, that we need to observe here. Barium, if taken, reactivity with cold water reacts rapidly. So barium, cold water means we are not rising the temperature, right? Means under normal conditions only, whenever barium is added to this cold water, that used to react very rapidly. This indicates what barium is having high reactivity, right? By seeing only we can observe, we can explain, right? So because of high rapidity of reaction towards the cold water, barium is susceptible for high reactivity. And being it is reacted very in the larger extent at the cold conditions only, with the steam we can't it is not required to be assumed, so that you can put a blank over here. Cobalt, whenever cobalt taken under reaction cold water conditions, so that no reaction is monitored, no reaction is observed, right? But whenever steam is introduced over there, slowly cobalt is used to be reacted whenever we are heating that one. Upon heating, cobalt will be reacted with the steam, so that we can say at normal condition reactivity is less, but whenever we are rising the temperature, so that slowly it will be reacted. Some extent reactivity you can notice. Magnesium, so with the cold water it will react very slowly, so reaction is there, but the speed of reaction is somewhat slow, not rapidity. So slow reaction you can notice, but under steam conditions, extremely higher temperature reacts very rapidly. Rapid reaction you can notice for magnesium. Okay. And this is the second one you can say. Barium obviously with the cold water of high reactivity. So that put a 1 mark, number 1 mark for barium. And the next is for no reaction cobalt, so that you can exclude this as a number 2. Magnesium reacts very slowly, so that there is a possibility reaction rapidly under higher temperature steam, so that this magnesium is marked as the number 2. And move on to zinc. With the cold water there is no reaction, means it is not that extent reactive. Okay, cold water no reaction is observed, but whenever you are going with the steam, react easily whenever heated. So easy reaction you can notice, so that spontaneous it will be upon steam conditions. Okay, put the third mark for zinc, and least obviously slow reaction, even under steam conditions slow reaction you can notice for cobalt. Put 4 mark for cobalt. So this is the way we can go for reactivity. So less reactive to be mentioned over, and most reactive can be put over in this box. Barium is of highly reactive even in the cold conditions, cold water rapid reaction noticed. Magnesium cold conditions slow reaction, but steam condition rapid reaction is observed. Zinc cold conditions no reaction occurred, but steam conditions you can observe rapid reaction. But in case of cobalt, cold conditions no reaction, even steam conditions there is a slow reaction. That's the reason why it is kept as the number 4. This is the way we can go with the reactivity. The reactivity purely depends upon time consumed for that kind of reaction, so that this is the entire data which related with the which related with the reaction of metal with the water, so that we can assume their rate of reaction. Move on to question number 3. Question number 3 is collected from JEE Advanced 2017 paper 2 question, and which is conducted by National Testing Agency. The correct statements about the surface properties are: surface properties to be identified. Adsorption is accompanied by decreasing the enthalpy and decreasing the entropy of the system, right? Whenever adsorption process is carried, adsorption is a surface phenomenon. So whenever the molecules got adsorbed on the surface, enthalpy will be decreased, entropy will be decreased. So this is the one which indicated with the right mark or tick mark. The critical temperature of the ethane and nitrogen 563 Kelvin, 126 Kelvin respectively. Adsorption of ethane will be more than that of nitrogen and the same amount of activated charcoal at a given temperature. So this is also correct one. Cloud is an emulsion of the colloid, which is a liquid dispersion phase in the gas is dispersed medium. Okay, we have to identify. Brownian motion of the colloidal particles does not depend on the size of particles, but depends on the viscosity of the solution. So this is all these regarding what surface phenomenon. Among all, only A and B are correct. Why C and D are incorrect? We will discuss all the things in detail. Okay, for this purpose, let's go with adsorption. In the adsorption process, delta H and delta S are negative. Higher the critical temperature of the gas, higher the critical temperature of the gas, extent of adsorption will be more. Okay, so cloud is not said to be an emulsion. Then Brownian motion depends upon the size of the particles as well, right? So these are the explanation for the whatever statements. Adsorption accompanied by decreasing the enthalpy and the entropy as well. So what they mentioned, delta H is called a change in the enthalpy, delta S is called a change in the entropy. Both are said to be negative. This is applicable for adsorption process. Then whenever critical temperature is higher, higher the critical temperature, higher the rate of adsorption. If you go for the critical temperature values of ethane and nitrogen, ethane is regarded as 563 Kelvin and nitrogen is 126 Kelvin. Okay, among all, ethane is having higher critical temperature value, so that ethane absorption will be larger in the extent. If you move on to 126 Kelvin, this is for nitrogen, its value will be lower, so that adsorption also smaller in the extent. Cloud is the emulsion they are saying, but cloud is not the emulsion. This is the explanatory part. Brownian motion colloid particles doesn't depends upon the size of the particles, but it depends upon the size of the particles. Brownian motion depends upon the size of particles is the correct answer. In order to explain all these, we will go with the one by one. First of all, in order to explain, first of all, we have to know what is adsorption first, right? Adsorption is nothing but any molecule is to be taken and another molecule is going to be reacted with this. Whenever another molecule is supposed to be reacted, so only surface is reactive towards that kind of process, but not the interior of that one. Okay, so any substance which having natural tendency to go for the reaction only on the top layer, irrespective of the bulk will not be participated, rather only surface region active towards another substance whichever coming. That is called adsorption. Adsorption purely the surface phenomenon, and the gas, liquid, or any dissolved substance which can be accumulated onto the surface of the solid. Whatever coming are called adsorbate. Whichever molecule is susceptible to get inside, that is called adsorbent. Okay, so on whose surface the molecules will be accumulated, that is called adsorbent. Which molecules are adsorbed are called adsorbates. Okay, adsorption is the process attachment of the molecule only pertaining to the surface region but not to the bulk. Okay, absorption is nothing but, so whenever molecules are coming, so they will diffuse inside, they will infused inside, that is called absorption. So adsorption is only for surface, absorption into the bulk. Okay, generally adsorbed materials are attracted onto the surface of the material, just like a dust can be accumulated on the surface of wall. Absorption occurs into liquid, adsorption mostly onto the solid. In order to go for the adsorption, solids are taken into the consideration. Absorption, liquids are taken into the consideration, right? So let's go with this phenomenon. Adsorption is the spontaneous process, so that will be carried itself. Okay, so that we can say it is the spontaneous process. Change in the free energy is negative. Delta G value is negative for adsorption process. Whenever change in free energy is negative, here delta G is equal to delta H minus T delta S is the thermodynamical formula. change in the free energy is equal to change in the entropy minus temperature on the Kelvin scale into change in the entropy, right? So delta H minus T delta S. For this exothermic reaction, delta H is said to be negative, and being it is the kind of molecular are adhering on the surface, so that its randomness get decreased. Whenever randomness decreased, so the delta S is also negative. Delta H negative, delta S negative, delta G negative. Whatever they mentioned in this option, adsorption accompanied by decrease in enthalpy, decrease in entropy, both are correct only, right? And the second one, move on to second. In order to explain the second one, adsorption of ethane will be more than that of nitrogen on the same amount of activated charcoal. Activated charcoal is the adsorbent here, on whose surface you are supposed to pass the ethane gas once, and another time nitrogen gas will be diffused. Whenever you are passing these two, ethane absorbed in the maximum extent in comparison to the nitrogen. That is because higher the critical temperature, more easily liquefiable gases, higher the extent of adsorption. Okay, so higher the extent of adsorption, for higher the critical temperature. Obviously ethane critical temperature is 563, nitrogen is 126. Comparatively this value is larger, so that ethane adsorption rate will be larger. This is the way we can explain, right? And another question will be answered. Cloud are the colloid dispersion of water in air. Okay, so here cloud is the kind of they are saying emulsion. The emulsion compulsory condition is one is liquid, another is also liquid. So dispersion phase is liquid, dispersion medium is also liquid, then only we can say that is emulsion. But the cloud is the kind of material where water and air. So this is the kind of, air is the gaseous one, water is the liquid one. So that it is not the emulsion. Emulsion is the wrong one, so that you can cut out the option number C. Brownian motion of colloidal particles doesn't depends upon the size of the particles, but depends upon the viscosity of the particles. They are saying. Let's see whether it is correct or wrong. Colloidal particles, colloidal solution, when viewed through the ultra microscope, shows the zigzag motion, which is called a Brownian moment. Whenever colloidal particles are inserted into the water, we can't see what is happening inside, but take the ultra microscope and observe under that. So that what happens, you can see all the movement, all the tiny particles are moving very random motion, which is called a zigzag motion. Colloidal particles are laying in the range of 1 nanometer to 100 nanometers range. Okay, Brownian moment is due to unbalanced bombardment. One is hitting upon another, so that it will change its path, and it is hitting on the surface of walls, so that it is changing its path. That's the reason why always molecules are moving zigzag, in the zigzag manner. Okay, so here the thing we need to understand is the motion is independent of the nature of colloid. What nature of the colloid is having, that is not matter for this Brownian motion, but rather it depends upon the size of the particles and viscosity of the solution as well. Size of the particles matter, viscosity of the solution also matter for Brownian moment. So they are saying doesn't depend upon the size, but depends upon the viscosity. Both are dependent properties only. Size dependency is there and viscosity dependency is there. So that you can cut out this option D as well. Only A and B are correct for question number 3. A, B are the correct answers. Move on to question number 4. Question number 4, the reaction taking place in a container, equilibrium with its surroundings, the effect of temperature on its equilibrium constant K in terms of change in entropy is described by. The reaction taking place in a container, equilibrium with its surroundings, effect of temperature on its equilibrium constant K in terms of change in entropy described by. Okay, so this is the question given from thermodynamics. Okay, so in order to explain this one, with increasing the temperature, the value of K for the exothermic reaction decreases because entropy change of the system is positive. Okay, so let's see the question very carefully. Whenever temperature increases, we are rising the temperature, right? So whenever temperature rises, and they are saying the reaction is said to be exothermic reaction. If this is the exothermic reaction, increasing the temperature is not required actually, but they are rising the temperature, then it will not become the spontaneous process. Always, for the spontaneous process, if the reaction is exothermic, then we can say entropy will be positive. For the spontaneous reaction, exothermic, if that is exothermic, entropy will become positive. But what they are saying, so here exothermic reaction, that is mentioned properly, but increasing the temperature, whenever you are rising the temperature, that will become non-spontaneous. For that non-spontaneous, entropy will not be positive, non-spontaneous entropy will be negative, so that you can cut out this option number A. With increasing the temperature, K for endothermic reaction increases because unfavorable change in entropy of the surrounding decreases. Okay. Whenever temperature rises, the reaction is said to be endothermic. This is the required condition only. So that's the reason why K value will be increases, because entropy of the surroundings decreases. Because entropy of the system increased, entropy of surroundings obviously decreases. This is correct one only. With increasing the temperature, the value of K endothermic reaction increases because entropy change of the system is negative. Entropy change of the surroundings decreases means negative, but system is negative means for the system it will be increased. No, delta S of the system is positive but not negative, so that you can cut out this option number C. With increasing the temperature, the value of exothermic reaction decreases because favorable entropy of the surroundings decreases. Surroundings decreases, but system increases. This is the correct one only. So this option is also correct one. With increasing the temperature, the value of K for endothermic reaction increases because unfavorable change in the entropy of surrounding decreases. Whenever you are rising the temperature, that is endothermic, so that it is the spontaneous reaction only. Okay. So for this spontaneous reaction, delta S system will be positive and delta S surroundings will be negative. That statement correct only. With increasing the temperature, value of K of exothermic reaction decreases because favorable change in entropy of surrounding decreases. So this is also correct one. In order to explain this one, with increasing the temperature, value of K for endothermic reaction increases, unfavorable change in the entropy of surrounding decreases. Okay. So delta S surrounding is equal to delta minus delta H by T surrounding. Okay. So here delta H denotes what? Delta H is the change in the enthalpy. T surrounding is nothing but temperature of surrounding. Okay. For endothermic reaction, T surrounding increases, delta H surrounding also increases. Exothermic reaction, T surrounding increases, delta H surrounding decreases. Okay. This is the one we need to understand. So with increasing the temperature, the value of K, right? The value of K for endothermic reaction increases, unfavorable change in the entropy surroundings decreases. Okay, with increasing the temperature, value of K for exothermic reaction decreases because favorable change in the entropy surroundings decreases. In order to explain, the correct formula is delta H surrounding is equal to negative delta H by T surrounding. Okay, so delta H will be negative whenever reaction is exothermic. Delta H is positive whenever the reaction is endothermic. Okay, so this is the way we can go for the delta S surrounding and the T surrounding, both are inversely proportional. Temperature increases, delta S surrounding decreases. Delta S surrounding increases, temperature decreases. So both are inversely proportional. And here delta is surrounding and the change in the enthalpy also inversely proportional, we can say, because the negative sign is there, no, so that we can say delta is surrounding and change in enthalpy also inversely proportional only. So this is the way we can, if you observe this relation carefully, entire things can be drawn in the proper way. So according to that, B and D are the correct answers. B and D are the correct answers for question number 4. Then move on to question number 5. This question number 5 is collected from Telangana MSET examination conducted in the year 2023. So which of the following is not able to form the buffer solution? Let me repeat the question. Which of the following is not able to form the buffer solution? ఈ క్రింది వాటిలో ఏది బఫర్ ద్రావణాన్ని ఏర్పరచదు? బఫర్ ద్రావణాన్ని ఏర్పరచదు. Okay. Ammonia plus HCl in the ratio. So apart from this composition, you have to go for the careful observation of mole ratios as well. Ammonia HCl taken in 2:1 molar ratio. Acetic acid and sodium hydroxide taken in 2:1 molar ratio. Sodium hydroxide and acetic acid taken in 1:1 molar ratio. Ammonium chloride and ammonia taken in 1:1 molar ratio. This is the way molar ratios are provided among all sodium hydroxide acetic acid composition. 1:1 is not feasible for buffer solution. Let's see how can we explain. What is the buffer solution? Any solution is said to be buffer. The buffer solution is a solution able to maintain the hydrogen ion concentration constant, pH constant. Only minor changes in the dilution, addition of small quantity of either acid or base. Right? Any solution was there. For example, it is the acid whose pH is 5. You're adding base to that one. After adding the base, what happens? Its pH will be raised. Okay, so whenever this is the acid, you're adding one more acid to this one, so that pH will be decreased. This is the way pH can be changed. But whenever acid is there, you're adding buffer solution to that one. Even by adding small quantity of another acid or else another base, its pH will not be varied, whose pH remains constant though you're adding acid or else a base. That is called what? Buffer solution. Buffer is the solution to maintain the constant pH, right? Solution of weak acid and its conjugate base or else weak base and its conjugate acid are able to maintain pH of the buffer solutions. So here the most important point to be remembered is weak acid and its conjugate base or else weak base and its conjugate acid. Both are able to give the buffer solutions. Okay. In order to explain this one, weak acid and conjugate base, how can we get? So for example, here the second condition to be applied here. Weak base and its conjugate acid. Weak base means ammonia is the weak base, right? So its a conjugate acid can be taken. What is that? Ammonium chloride. One is ammonia plus ammonium chloride. In order to get ammonia plus ammonium chloride, you need 2 moles of ammonia. Yes or no? That's the reason why 2:1 ratio you are taking. This is perfect. And here weak acid taken. Weak acid is the acetic acid. So, and it's a conjugate base. How can you get another sodium acetate if taken? That is called conjugate base. So, in order to get one acetic acid and one more sodium acetate, we require 2 moles of acetic acid. That's why 2:1 ratio is perfect for second one, which is the acidic buffer. And move on to third one. Acetic acid is the weak acid only, but sodium hydroxide is the strong base only. But here, in order to get its conjugate base, we are not having 2 ratio. 1:2 if mentioned, that will be correct only, but 1:1 wrong one. This will not give buffer. This is called a neutral solution or else a slightly basic solution. We can't get a buffer by means of this kind of combination. Move on to fourth one. Here also 1:1 molar ratio is there, but it is called a buffer solution. How can we justify? Because if you see this ammonia is called a weak base. Ammonium chloride is called it's a conjugate acid. So that this is the need not to go for the preparation, already prepared buffer. This is the actual composition of buffer we got. So that both are required in 1:1 molar ratio only. Let me repeat that. Weak acid and its a conjugate base or else weak base and its a conjugate acid. This combination is required to prepare the buffer solution. This ammonium chloride ammonia is called a weak base and it's a conjugate acid. So this is called a weak acid conjugate base. This is called weak base conjugate acid. So in this manner, the buffers can be synthesized, but NaOH plus acetic acid 1:1, this is not the buffer solution, right? So this is the way question number 5, option 3 is the correct answer. Move on to last question of the session. The alkali metal with the lowest E naught M plus by M is X, and alkali metal with the highest E naught M plus M volts in Y. Then X and Y are respectively. Okay. Alkali metal with the lowest E naught M plus M volts in X, and the alkali metal with the highest E naught M plus M volts in Y. Then X and Y are respectively. Okay, so lowest E naught value, highest E naught value with respect to alkali metals we need to answer. కనిష్ట E naught M plus M volts గల క్షారలోహము X మరియు గరిష్ట E naught M plus M volts గల క్షారలోహం Y అయినచో X మరియు Y లు వరుసగా. Okay, in order to answer this we have to go for the table that is called a galvanic table, or else we can say electrochemical series. Okay, let's see the electrochemical series for alkali metals. Standard electrode potential values for M plus M are provided over here. If you observe clearly, lithium is having minus 3.04. Negative 3.04 means it is the least value. As the negative value increases, the value will be decreased, right? So everybody know that. So minus 2, 0, plus 2 if present, minus 2 is the smaller, 0 is the in between, 2 is the larger value. If you compare minus 3 and minus 2, minus 3 will be the smaller value. And sodium if taken, minus 2.7. Potassium is minus 2.9. Among minus 2.7, minus 2.9, which is smaller? Sodium is larger. Because the smaller the value, larger the quantity, because negative sign is there, no? So that minus 2.9 is the smaller value, minus 2.7 is the larger value. Again for rubidium, you can notice minus 2.9 only. Cesium also having minus 2.9 only. So this is the way if you go for the electrode potential, standard electrode potential values, highest value is accorded for sodium because minus 2.7 is the largest value among all. And lithium is having minus 3.04. This is the least value, right? Least value is for lithium, least value is for lithium, highest value is for sodium. So this is the table required to be remembered. Then only we can answer this. There is no logic behind this, so that the table is required to be remembered. Then only we can answer this type of question, right? So by this we entirely completed the session, and we gone through the various sections of the chemistry and various dimensions got covered over here, so that it is really interesting session, I can say. And the problematic session we got covered with logical reasoning. We gone through the colloidals and adsorption process. We gone through the inorganic periodic table related questions are given to you, and organic content is also covered. Nobel laureates are specifically mentioned over, and various segments got taken into the consideration, and reactivity order got compared, so that it will be really informative, and moreover I can say interesting as well. So that like the channel and comment. In order to comment, we have a question over here. In order to answer the question for the day, in the process of adsorption, I'm going with the surface chemistry phenomenon. In the process of adsorption, here various kinds will be there. Adsorption, adsorbent, adsorbate, adsorption process will be there. In that, different solutions you can go for. One is called emulsion, another is called sol, aerosol formation will be there. In this way, how many combinations are possible? You have to put a comment over here. I'm going with the liquid and liquid combination, that is called emulsion. In this manner, if you are going to add the different compositions of the physical states, how many forms of colloids you can notice based on the physical state of dispersion phase and dispersion medium around the central adsorption process, how many possible colloidal solutions you can prepare. This is the kind of classification we can say that can be taken as the comment question. So you can put your answer in the comment box for this session, and share with us parents who are more serious about the preparation, and subscribe the channel. We can go for the more new content in the near future. Definitely you will achieve whatever you are aspiring if you are seriously observing, seriously going through the entire session. Thank you very much for your patient listening.